So hello world, I'm excited to be here. It's kind of cool to be like in the same mental space as people like across the whole entire world. I think we're all kind of here driven by the same goals to like automate our infrastructure, maybe solve compliance problems. Maybe we're migrating from off on-prem to the cloud or maybe going back. And the open source community has really been a big part of even just my career in the past 5 years. I moved to infrastructure. I worked in like machine learning in the past, and a lot of times when I worked in there, it was more like research driven. A lot more things weren't as practical. But I always find like infrastructure open source very engaging. Not as fun as some of the proprietary software. Some of the proprietary software communities are really good, but it's really been great how HashiCorp has continued to like strive for adoption just across the community as they even built out their proprietary platform. And they built a lot of really good tools that we can use to find a way to automate our infrastructure. And when I think about like a traditional sysops person, they always like have tricks and cheats. Like whether it's like an outage or whether it's just a day-to-day, they have some type of bash script on their machine that they're like using, and whether it's JQ or where it's other some Linux type of command line tool. But I think it's really awesome that HashiCorp took the time to like find a way to create an interface for us to be able to provision infrastructure across many different resources. So they pretty much took that foundation of a sysadmin and helped to make it scalable across the community. So I currently work at Oscar Health. We're a health insurer, but I like to say that we're a healthcare company because we're also trying to what we consider refactor the healthcare experience. We've been very aggressive with open source tools. We've been running Console, Vault, Packer, and Nomad even before they were on major versions. Some of them aren't even on major versions yet. Because of this, like some of the open source projects weren't necessarily mature yet, but we were running them as first-class citizens in our infrastructure. And because of that, we need to integrate with other services that we had in our systems. So let's kind of talk about it a bit. So when I just took a screenshot of like open source software at HashiCorp, of course you get these like 4 top ones of Nomad, Terraform, Vault, and Packer. These are things that everyone talks about. But today there's a lot of other treats that I'm kind of going to mention towards the end, but I want to focus on 2 that I find really helpful that you can maybe use when you leave here today, and that's GoGetter and consul-template. So we're going to talk about GoGetter, some of the protocols and detectors there, and then some of the ways that you can use it through code if you wanted to write a service. And then we'll talk about consul-template. I'll spend a little bit of time giving a little overview over Consul just to give you an understanding of what Consul can do from a core competency standpoint. And then we'll talk about some of the internals with consul-template. And I'll briefly go over some other open source projects that you might find useful as well. So GoGetter. So GoGetter is simply a source and sync system. Basically, you have a source of some configuration or some keys that are somewhere, and you want to be able to put them into some sync or some destination. And so this package downloads things from a string URL, and it uses a variety of protocols. This removes the burden of knowing where to download things from various sources. So let's look at like a command line example. So here in the command line, you can initialize like GoGetter once you download the binary, and you specify a GitHub URL. And then the next argument is a directory within this repository that you just want to clone specifically on its own. This is essentially like how Terraform modules work. Terraform modules uses GoGetter to pull modules from some resource. So that's why it's so easy to specify a different, like when we say source from your modules, whether it's S3 or Git, Terraform's able to easily go get that. And you could use that too in your project. So there's 2 concepts to kind of think about when you think about GoGetter, and these are protocols and detectors. Your protocols mainly in GoGetter today are mainly like Git and HTTP calls. Most of the calls are done through HTTP. And so protocols are used to download files and directories using a specific mechanism. Example protocols are like Git and HTTP. And detectors are used to transform a valid or invalid URL into another URL, which matches a certain pattern. So in the previous example, like github.com/foobar, it's automatically transformed into a fully valid Git URL. And this allows GoGetter to be very user-friendly. The next thing I'll mention, and forgot on this slide, is that you also can pull from S3 or GCP. These are the different detectors that are in GoGetter today. So then you have this other concept of force protocol. So you might have some cases where a protocol is like too ambiguous and depending on the source URL. So for example, if we look at this first one, it's just HTTP github.com/mitchell vagrant.git. And Go Getter is like, by default, it's okay, it's a HTTP request, but maybe there's some way that I can optimize or maybe use some of the native third-party APIs to like pull this source down. So you can actually specify the protocol for your source that you want to pull from. So you would add a colon, 2 colons in front of your URL, prefix with the protocol that you want to use. So GoGetter is able to do this on its own. Once it pulls that URL down, it'll try to transform it, detect what type of URL it is, and then use a sophisticated getter to go get that. So let's look at some of the code examples a little bit, and I'll briefly talk about like how the Git works. So it clones the entire repository kind of in memory, but on disk, and then discards everything that needed. So be mindful that if you work in a monorepo or you store artifacts in your Git repository, so using GoGetter to pull down big binaries and then it has to go down and delete and discard everything, like pulling it from Git might not be a good idea. One of the reasons why it works for us is because we actually run all our repos in mono repos. I'm a big component of a mono repository, but because of that, we had kind of like a big surface area when we want to apply Terraform changes. So we wanted to have a mechanism when we want to run our Terraform where we can only pull down a given workspace and only apply Terraform for that workspace that we found valid. And GoGetter provided a really nice interface to do that. So cloud storage is pretty straightforward. It just leverages the Google and Amazon's APIs for their storage. If you're not familiar with cloud storage, it's like an object storage and a cloud that you can use to store binaries, configurations, whatever you want. Here, it's pretty optimal because it's able to leverage the Amazon APIs to be able to just pull that key value path directly down for you or whatever you're searching for. The one call out that I would say that is probably a little bit better in the Git flow is that you do have a code review process for this. With S3 or these other backends, you might not necessarily have like a review process, but you can control it through ACLs, determine on what resources that you want to allow in Git. So how would I use GoGetter? Like if I didn't want to just use it as a command line tool, maybe I wanted to like write a handler or RPC service where people can pass JSON or RPC calls to my service and they can always be able to run something that's in Git or S3 or cloud storage is already generally extracted for me. So you have this detector interface and it's going to be a few Go slides here. But this is where we define whether interface is an invalid URL or not. And if the schema is passed in order, determines in shorthand if it's well known for something else. So let's say you had another URL that you wanted to support. Maybe you wrote your own cloud storage system, or maybe you want to integrate with another backend that GoGetter has implemented. You need to come up with your own URL schema and write how GoGetter will detect that schema. And then I'll just give an example that's in code, but here we are going to initialize a GitHub detector. Most of the detectors are initialized by default, but if you're doing this through code, you might just want to initialize the specific detector that you want to use. So here there is an interface with GitHub detector that implements that, that detector interface that is able to detect whether or not maybe SSH is needed. Is there any other features from GitHub that we might leverage from this solution? And then let's look at this Getter interface a bit. There's 4 methods here. Git is mainly used to pull a whole entire repository. And then Git file is for cases where you want to pull a very specific file. And of course, there are some optimization decisions that you would make here, and that's why those methods are separate. And then there's 2 other methods you have to implement is a client mode. This helps like reduce strain from clients to know what mode they should be in. So this will return a mode for you to be able to do like special, use other methods that might be associated with that mode. And the mode could be like GitHub or S3. And then you can set a client. So this is a way for clients to know progress tracking or use some of the Git methods to be able to do stuff. And I'm going to give a little bit more in-depth example. We're kind of moving along the example I'm giving, but here's like a getters, and then this is like the Git getter, because Git getter is specific to how we want to get. And this is stored in a map, so you actually kind of specify like, hey, it's Git, or it'll be S3, and then you'll use that S3 getter. So we load that getter up, and then we want to create a new client. So let's say we do have a handler. Usually in a handler, you'll pass in some context. Maybe you might have some metadata or some duration to cancel this request, but let's not focus too much on contexts. You have a destination where you want to store from where you source your stuff. directory, you set it to true if you want it to be, if you want to specify it to be a director. And let's say we'll just pull down this source directory, which is a Terraform repository from GitHub. And then we'll specify like a client mode directory so people know how to interact with this client. And because we're just going to pull down a directory, here we can just do client.git. And this doesn't return anything but an error, but here you can do something if your go-getter process failed, you can catch this, maybe still an error back to the client. Here, like when you do load up this client struct, you do specify the destination. So you'll need to keep track of this destination. So if you want to like traverse through that directory or anything that you did there. So that's something to keep in mind. Here, I'm just, if there's an error, I'm going to print that out and exit status 1. So we kind of talked about some protocols with go-getter, maybe some use cases of why you want to use it, some downfalls of it, how you can maybe implement it in Go if you wanted to like write your own service and didn't want to do it just straight bash scripts. But it's pretty easy to just use go-getter as a binary in a bash script and do other things around it. So now I want to spend a little bit of time talking about console a little bit because we're going to transition into console template. And I want to spend a little bit of time talking about how I kind of view console. I do use console as like an army Swiss knife. I do so many things with console, it probably is super embarrassing to say, but it's a powerful tool. And I look at it as like a data center service and monitoring tool. I know a lot of people at HashiCorp do disagree with me on that, but let's talk about some of the ways that you can use console. So let's look at the 1,000-foot view of console. You'll have essentially maybe 2 data centers for like redundancy, and you'll have your actual console servers. And these console servers have like an agent model, so you deploy what they call clients on multiple machines. I'll use the term nodes to describe a client typically because I normally deploy one client on one given machine. And that client is responsible for sending metadata back to the server about maybe what node ID this is or other services that might be running on a machine. But also these clients will go back and talk to the servers to get some values or anything that's in console. So that's a high view. There's some networking too as well, networking here too as well because console also provides like a DNS. And so here's like when you get console kind of started, you see this like console service, you'll see a health check in green because there's a health check being ran against this service. And you can actually associate like tags with this service too as well. And you actually can query these tags with the combination of DNS service that console provides. It's super amazing. And this is an example, like I love to just, even if I have a cron running or I have a long time running service, I love to just be able to register my services in console. Because if maybe I get an alert for like a spike of CPU or something that's going on, I don't have to like get on that machine to actually see what's going on. I can kind of see what processes are running through console, and I can see what processes are attached to what node. So that's very powerful for me to do through console. Another thing is the check system. So here is like statsd exporter. You might, exporter is like a way to export metrics from your system. So typically you might have these run across all your hosts. And this is an example of just a simple TCP check that console can provide on behalf of your service. If this check did fail, console will roll this service out of service discovery and no one will be able to like hit this service. There's a way to make a warning that people can get notified when it's like a warning. It doesn't roll it out of service discovery, but usually depending on the exit code from that check depends on how it is registered. So some cool stuff here. And then one of the last like kind of core things, there's so many other things you can do with console, but just simply the key value system. So you can store key values in there. They can be configuration files. They can be just regular keys and values, anything you essentially want it to be. So now that we talked about console for a bit, let's talk about console template. You actually don't need console to run console template. I guess console template was such an early project, they just decided to call it like console template. But I'll give some examples of using console template without console. And so usually people want to use, or engineers want to use console template when they want to dynamically load configurations. And we're going to look at some examples for that. So you can get your values right now from 2 places, essentially like in the code, and that's through console and vault. So if you already have console in your environment or you already have vault in your environment, it can rely on the default configurations that's in your environment and be able to run with it already. So whatever ACLs on that token that is applied on your machine or for your service, console simply can respect that and get credentials. So if you ever wanted to maybe load maybe you run a vendor service that doesn't support dynamic database credentials, but you want to be able to like maybe refresh those database credentials on some interval. Consul-template can read dynamic credentials from Vault, and then you can write that to your configuration and then trigger reload. So we're going to look at some command line examples from that. So it's a very simple example, and I would say like consul-template is mainly used to be a daemon. I'm going to show some code examples so you can understand how it kind of works. I've been not sure the right term, I'll come back to that. But here we'll build the console binary, have it on our machine. We specify the template flag. The syntax is a little bit weird here, but on the left side of the colon, we have n.template. So there's some type of configuration here that we want to get out. And then we want it to go to a destination of out.text. And then we only want to do this once. So we specify the once flag. So this will only run once. It won't spin a background process. And so let's look at like what a example without even console at all. Let's just say I have a file on the system and it's located in local bin and it's just foo. And inside that foo file is just bar. And so console will render this out for you into a file of your choice. And this is kind of an example of me just in a Docker image where I just created a temp directory with like an example part template and a file called foo. I run that. And then now I actually have bar.text with test data inside cat.foo was test data. So this is just a very trivial example. The next example is when you want to get keys out of console. So you specify key, and then you specify the path that you want to get, and this will render out the value. So this is like a trivial example for getting a Redis max connection. So maybe every time someone updates the value in console for a max Redis connection, you'll go and reload console. And so let's look at like how you would kind of do this through code in the once mode. This is a very simple example. So you have this new template input. This actually can take a source or contents. We'll just say we have some directory on the system called foo. We'll put this into a new template and we'll get a template back. And then we can go and execute this template. This template doesn't provide the ability to specify like a destination. So what you'll get back is the actual contents from the template rendering. And then from there, you have to like write to wherever you want. Here in this example, I'm just writing to output. But it's very short lines of code. Most of it is just the error handling here to load this up. And let's talk about kind of these structs. So in a new template input, you can either specify like a source or just contents and load that up. There's another one called error missing key. So if you're loading from console or loading from some resource and that key is missing, how do you want console template to handle that? You have left and right dilemmas, which are used to dilemma templates. And one thing I really appreciate that's in here is function blacklisting. So there's a lot of functions that you can use in console template, but maybe you want to provide ACLing around what templates can use what functions. You can specify a list of functions that you don't want to enable a template to run. And then there's actually another thing I really enjoy is the sandbox path. So you can list a bunch of paths that you only want console template to be able to work in. So that also kind of isolates the environment of what console template can do. And then you have the exec input. There's this other concept of like a brain. I don't want to spend too much time on brain, but really the brain, it's like the brain of console template when you're like running it. It's keeping all the key values and information in kind of memory and being able to know like how to reload those key changes when it needs to. And then you can specify some environments for your exec input too as well, but you don't necessarily kind of need this to run it in once mode. And then there's some things that kind of do go into the brain struct. It has some locking there to be able to handle with some concurrent issues. It has a data map for individual dependencies and like the most recent data that is there. And then a received data kind of map that helps do internal tracking of which dependencies have stored data. So let's talk about a little bit of advanced usage. Hopefully it's a little bit aggressive on the code here. So hopefully no one gets kind of lost. But here is like the configuration docs for console template is very good. I'm just going to kind of highlight some here. So you have like console and vault by default. You can specify things like outside of your local environment if you wanted to load it up. There's an exec mode. Exec mode came in console version 0.16, and it gives you the ability to maintain an arbitrary like child process. This mode is beneficial for when you want to run console template like in a container or a scheduler like Nomad or Kubernetes. When activated, like console template will spawn, manage a lifecycle of a child process. So this mode is best explained kind of through an example. So consider an application that reads a configuration file from disk and then spawns a server from that configuration, which we kind of talked about with Redis. You also can specify like kill signals, a PID file, and a reload signal. And you also can do stuff with syslog through consul-template. Another cool thing with like even just in one kind of command line tool or consul-template, you can render out multiple templates at one time. And this is a little bit more advanced example where here in the first half, we kind of have what we want to template out as Nginx config. And then we have the destination that we want Nginx to write to. And then we're going to actually run a command after this. There's actually a command option with consul-template too. So you actually can execute a command after your consul-template has run. So we're actually, every time the template does change, we're going to reload Nginx, or we're going to reload Redis. Or we don't have to reload anything. We can just add the configuration there. Maybe you have systemd monitoring that service or some other supervisor on a machine. And in a template configuration, you have backups. So you can actually back up a configuration before it gets applied. You can pass in contents, the same thing with a source. You have the error missing key, and then you actually have the function blacklist and sandboxing too as well that you can define. And there's like this manager package in consul-template, which helps you kind of spawn off that child process if you want to do that through code. Instead of specifying the once command, you would specify the exec command if you wanted to spin off in a child process. But let's try to look at an example where he's spinning off kind of this runner. They call this a runner. And here we're just going to pass in a default config. We don't need much. They give you kind of a default config you can load your environment in. If this runner kind of fails to get started, we'll just return an error. We're going to initialize a buffer here because since consul-template kind of spins off a thread, it's actually going to write to different outputs. And so we want to be able to kind of catch that output so we can know if something's writing to standard error, standard out, and be able to kind of act on that. And then we're going to actually spin off a Go routine, but I'm just going to use the word thread to keep it simple if people are not familiar with like Go. So we're going to start this thread of like this child process of consul-template. And then in Go, you have a keyword called defer, which you can defer like something until the function has reached the end of its life. So we're going to stop the runner if this function does finish. And then we're just going to run the runner. That might not have been the best name. And then this is how you can kind of wait for the runner to be done or not. So we're going to start an infinite loop, and then it gives you 3 channels back. You get a channel is kind of like something to listen on and go. And so you have an error channel. So if it does signal error, you can do something. For this example, we'll just return it to the client, but maybe you might want to try to figure out a way to handle that error if you might know what it is. And you have a done channel. So if consul-template is done rendering, you'll get hit done. We'll just return nothing back, but maybe you might want to write test cases for your consul-template because of uploading like some binary for linting might be too expensive. So you might want to actually write tests here. And then if none of these other cases are true, let's keep rendering this template. And this is how you have consul-template running in Go code just in the background process. One of the last thing I kind of want to talk about is a plugin feature with consul-template. So if you don't want to necessarily like kind of write code, but you may have other sources that you want to read from and not, maybe it's not the proper thing to put in console. And so these are for cases where it may be necessary to write a plugin that offloads it to another system. This is especially useful for things that are not in the standard library of consul-template, but should be shared across multiple instances. And so there's pretty much kind of 2 things you need to take into consider when writing a plugin. The name, you'll probably just load this up into your path. So consul-template can go execute that binary. And then the next thing is the input, and the input is from the template. So this will be like an argument that is passed in. And this actually got kind of cut off, but the argument kind of contains a white space. It will quote it with a string, with quotes. And so there's an example from a guy named Robbie in open source. He published this EC2 consul-template plugin. EC2 is Amazon's offering of like a machine, whether Linux or Windows, and you can get metadata from that machine when you build it. It could be the instance size, the configuration of it, or tags that you associate with this machine. And you might not actually store this information in consul-template, but it might be valuable to have some information from AWS when you're actually rendering a template out. So you don't even have to write Go. You can write in Python, you can write in Ruby, you can write in Bash. And we'll show how to initiate this plugin. But all this really does, I don't have the full code example here, but this just leverages the Amazon APIs or Google APIs, whatever they are, to just get that instance metadata and then to print that out in a JSON blob. So here, if you want to initialize this in consul-template, you would specify plugin, you would specify the binary, and then an argument. So we want to render out placement region, which will give us the region for which our instance is in. Pretty simple example, but pretty cool that you can kind of do this right out the box. And so these are pretty much kind of my final thoughts on those two projects. I think they work well together in a system where you might want to deliver Terraform in a way that you might not want to like actually check in Terraform code. Maybe you already wrote a module where all you need to do is load variables there. And so maybe you want to read that from consul-template, use GoGetter to pull down your Terraform repo and your Terraform module and load up that Terraform environment. And then you actually have a way to reproduce Terraform without even actually having the Terraform code, because you actually have most of your social truth content in console. You can always go replay that from console and verify with the remote state. So it's kind of pretty awesome to do if you didn't want to manage like a bunch of TF files and had like a really nice interface for your modules. And then here are some other open source projects that are really cool that I enjoy. So Surf is a decentralized service discovery mechanism for simple use. I believe it's what Consul uses internally. Consul Replicate, that helps you replicate Consul keys over from one machine to another. I think this is kind of provided in the proprietary solution of Consul. Consul ESM is an easy way to monitor Consul services, which I think is super awesome. It gives you a lot of stuff out of the box that you don't have to kind of go code yourself. Go Discovery is a really nice package that you can use to find nodes in your cloud environment. So you just wanted a simple like node discovery tool. Go Discover gives that. And then Go MemDB helps you store radix trees and memory. And then Member List is another cool library to help manage cluster membership and member failure detection using a gossip protocol. There are cases and such. A library is far reaching, so a lot of distributed systems require like some type of membership or a membership list to determine like if a node had failed or not. One other call out from consul-template is that consul-template is also used in the Vault agent to do some work too as well. So that's another call that I missed earlier. But that's all I have for today. Thank you.